Welcome students. I come up with another question from the Varignon's theorem. Okay, based upon the Varignon's theorem, the question is the three forces and a couple shown in figure are applied to an angle bracket. Find the first question is resultant of this system of forces. Second one, locate the points where the line of action of the resultant intersect. Okay, so this is the given picture for us. It's a angle bracket. Okay, in the L shape, the angle bracket is this point is specified as A and this point is specified as B, whereas here from the intersection of both the lines we have a force. I just going to take this as O. Okay, let it be. And the force acting on the A point is 50 Newton and force acting on the O point, which is 125 Newton, and on the B, which is 200 Newton. So both the A and B has the vertical and horizontal forces. Here it is inclined force. Okay, so to find, by reading the question I understood, we need to find the resultant. First one is a resultant, and the second question, it is been said locate the points. So location of the resultant we need to find. That's all. So that means here the angle bracket which has x coordinate and y coordinates, so definitely we need to find x and y in order to specify the location, right? Fine, let's get into the solution part. So in order to solve it, first identify what are the forces acting on the system. Here I said one vertical force and one horizontal force and one inclined force. Along with it, one couple is there. That means moment is given, which is 8 Newton per Newton meter, which is a notable one. Okay, right. So in order to show the force, I just going to show the angle in such a way. This is O point and B. Okay, and the point which is a 50 Newton, so no worry, just directly we can take this as 50 Newton, and here which is 200 Newton, so directly we can take it as 200 Newton. Okay, and here which is a inclined force. Okay, so that I can say if we are coming across the inclined force, partially horizontal and partially vertical, am I right? So here comes, since the force is moving in such a way, I can say it is moving vertically upward and horizontally right side, horizontally right and vertically upward, so something like that. So here comes the designation of the force 125 Newton. It's a horizontal, so cos 60 degree. This inclination is given with the horizontal, so directly we can take it. So here 125, it's a vertical component, so sine 60 degree. That's all. Okay, so this is how this arrangement is. And here the moment, don't miss it, so which is 8 Newton meter. Okay, so first let me start to identify the magnitude of or resultant. So for that, resolve sum of horizontal forces, summation of h. So here add all the horizontal forces. Here comes two horizontal force, one is 200 Newton, okay, and which is directed towards negative side, that means left side, so it carries negative. Okay, and if it is directed towards right, then it is a positive. So this was 200 Newton, it's a negative, and here comes one horizontal force is there which is directed right side, so which is a positive one. Okay, so plus 125 cos 60 degree. Okay, so two force alone, just do the calculation, you will get minus 137.5 Newton, minus 137.5 Newton. So this says the horizontal force Therefore I can say sum of horizontal force which is equal to 137.5 Newton. This minus sign says which is just directed towards left side, horizontal left side. So remove it and just note which is moving towards left side. Okay, what is next? Resolve sum of vertical forces. So sum of vertical forces, add all the vertical force in the system. So vertical force 50 Newton, 50 Newton and 125 sine 60 Newton. Am I right? So 50 Newton which is directed towards downwards in the sense it carries negative sign, upward in the sense it's a positive sign. So this force carries a negative sign, and as far as this sign, that means this force 125 sine 60 degree concerns, which is towards upward in the sense it's a positive sign. So whether we need to add this one 8 Newton meter which is a couple, so it does not comes under either on the horizontal force nor on the vertical force. Okay, keep it in your mind, it's a couple, okay, which is given Newton meter. All the things are Newton, but it is a Newton meter, so just keep it in your mind, which cannot be included in sum of horizontal force or sum of vertical force. Okay, if you add it somewhere on horizontal and vertical, it will be a wrong answer for you. So just do the calculation for this sum of vertical force. I hope you will get 58.253 Newton. Okay, sum of vertical force. Here it's a positive value, so it says it's just moving vertically upward. Okay, so here it is negative, so it's a horizontal, so horizontally right left side we predicted, here it is towards upward. Okay, now magnitude of the resultant. So magnitude of resultant can be calculated or is equal to root of summation of h the whole square plus summation of v the whole square. Sum of horizontal force is 137.5 the whole square plus 58.253 the whole square. Okay, that's all. So do the calculation, you will get the answer for or, which is 149.33 Newton. This is the resultant magnitude. So we need to find the location. So in order to position it, definitely we need the direction of the resultant. So we can find the direction of resultant. Alpha. That formula is tan inverse of summation of v divided by summation of h. This is known for us. So tan inverse of summation of v, answer is 58.253 Newton divided by 137.5 Newton. So that you will get the alpha answer 22.96 degree alpha. So this is the answer for alpha. Once we got the alpha and or, we just identified in which quadrant it's gonna happen. Okay, the resultant force going to have. So here sum of horizontal force which is directed toward lefts. Okay, towards left. So somewhere here we are going to have the horizontal sum of v, the sum of horizontal force, and vertical force it is what, which is directed towards the upward. So somewhere here we are going to have. So if it is summation of h and summation of v, so in between both the summation of h and summation of v, we are going to have the resultant force. Okay, so that keep it in your mind. And here the alpha inclination, we already the value is found. So this with respect to the or resultant force with respect to horizontal, which is 22.96 degree. That's all. Okay, so now we have just predicted the place in which quadrant and which direction the resultant and which is going on. Okay, so we have predicted. What is the next step? Next step is identifying the what? The location. Location. In order to locate it, first we must know about the what? The moment. Sum of moment. Just try to apply moment so that we can get the perpendicular distance by applying the Varignon's theorem. Okay, so first apply sum of moment. Here I going to take about O. Any point we can take about A or B, but I going to take about O, this point. So we know when you are taking about the point O, keep it in your mind always. If you draw a cross lines, I said in the previous question, if you draw the cross lines, okay, this is a horizontal cross line, and if you draw a vertical cross line, it moves like this, right? If any force just come into the line, okay, here comes the horizontal, this force is coming into the line, and here comes the vertical line, this force is coming into the line. So thing is, what are the line is coming into the line? It will be a 0 for moment. Why? Because 125 cos 60 degree, we are taking about O, whether it has the perpendicular distance. No, it is just taking from the point O. Am I right? Just taking part from the point O. So definitely there is no perpendicular distance, so it will be 0. It won't take part in the moment. And here comes 125 sine 60 degree, which also taking from O. There is no perpendicular distance. Perpendicular distance is 0. So this also won't participate in the moment. So any other force is coming into the cross line? No force is coming into the cross line. Am I right? No one is coinciding. No one is, only these two coincide. Okay, let it be. So 50 and 200 Newton force is there. 50 Newton we can learn first. So 50 Newton force into its perpendicular distance. Perpendicular distance here it is mentioned as 300 meter. Okay, this is 300 meter. So this distance is 300 meter. So 50 into its perpendicular distance about O, which is 300. And what about the direction? So this is how the frame is, and the force is acting from the upward, right? When it acts from the upward, how the bracket will move? In the which direction? Anti-clockwise direction. It moves in the anti-clockwise direction. When you are just rotating, it will be anti-clockwise direction, so that it's a minus sign. And just do it for the 200 Newton force, which is acting something like this. So if I apply the force, how it rotates, the frame will rotate in the which direction? Clockwise direction. So it carries positive. That force is an anti-clockwise direction. Here it is a clockwise direction, so it is a positive. So 200 into its perpendicular distance. So this is the O to B is a perpendicular distance, which is 200 meter. Am I right? 200 meter. So multiply by 200. Okay. And then see, here we have the couple. Okay. This couple I said it won't take part in summation of H and summation of V, but in the moment it take place. Okay. So this couple can be calculated here. Okay. That means 8, which is given, and look where it is moving, in which direction it is moving. This is moving in the anti-clockwise direction, so it carries minus. Okay, now just do the calculation. Okay, just feed it in your calculator, and I hope when you are calculating it you will get 24992. Okay, 24,992 Newton meter. In terms of Newton meter, we will get moment about O, right? So the next step is just try to apply the Varignon's theorem. Okay, Varignon's theorem. Apply the Varignon's theorem. So when you are applying the Varignon's theorem, we know sum of moment about any point. Here it is taken about O, which is equal to resultant moment, or into its perpendicular distance small r. So this is the thing. So when you are applying it, sum of moment about O, which we have found, which is 24992. So 24992, which is equal to resultant, we got how much? 149.33, okay, into its perpendicular distance. So R will be, when doing cross multiplication, 24992 divided by 149.33, we get the R value as 167.36 meter. So this is the perpendicular distance of the resultant. We need to find the x and y in order to specify it, since the bracket has the x coordinate and y coordinates. Okay, so in order to find it, I said in the previous problem also, we need to apply the resultant force about the summation of h and summation v independently. We need to apply the Varignon's theorem. When you apply it, we get, when you are applying for the summation of h, we get moment about O, which is equal to sum of horizontal force into its perpendicular distance, which is y, for sum of horizontal force. When you apply for the next one, sum of vertical force, we will get sum of vertical force into x, something like this. So one by one we can just substitute it. So here I just going to take the first one, sum of moment about O, which is equal to sum of horizontal force into y, so that we get y answer when you're simplifying sum of moment about O divided by sum of horizontal force. So moment about O, we know the answer 24992 divided by horizontal force we just found, which is 137.5. 137.5. So just do the calculation. Y answer we will get when you simplify it 181.76 meter. And when you apply the next equation, sum of moment about O, which is equal to sum of V into x. Okay, so here we can get the x answer. Okay, we can get the x answer. Sum of moment about O divided by sum of vertical force, we will get moment value we found 24992 divided by sum of vertical force, which is 58.253. 58.253. So here just do the calculation. I hope for the x we get 429.02 meter. In terms of meter we will get it. Okay, what is the next step? X, y, it is found. Next step is the result. So in order to plot the result, just have the arrangements of this bracket, angle bracket. So this is how the bracket arrangement is. Okay, so this is the point A, this O, and this is B. Okay, so here where the resultant will fall on. See the resultant force, which is just going something like this, we have predicted. Okay, somewhere here, this is how the resultant force is going to happen. What about the moment? Moment which is moving in the clockwise direction. Here it is a positive sign, right? So it is moving in the clockwise direction. That means this is how the moment is, clockwise direction, positive. If it is negative, then it is a anti-clockwise direction. Here it is positive sign, right? So it's a clockwise direction. So when you are placing the resultant force or on the frame, it should rotate about O in the clockwise. So if I keep here somewhere here, if I keep the resultant force, then the resultant will be rotating in anti-clockwise direction. But if I keep in the left side of the O, something like this with the same inclination, I can say now it will rotate in the anti-clockwise direction about O. So this is how the resultant force need to be placed. Okay, fine. And when you mark the x, so here will be the x distance, and when you mark the y distance, so this would be the y distance. We can take the measurement as well, and when you mark the perpendicular distance, or so from the line of action, if you take the 90-degree line about the point O, you'll get the R. You can note the R. And the alpha where we can note, so here we can note it down. Okay, so here the alpha, which is which is which is we got in 22.96 degree. Okay, so this is the resultant. Not to specify it, I have taken the angle something like this. Okay, right? So this is how we need to place the resultant force when you're having such kind of conditions. So I hope you got the procedure in which manner we need to go in order to specify the all the things. Okay, always remember, when you're going to specify the location of anything, we need to apply the Varignon's theorem. Okay, so by the help of the Varignon's theorem only we can carry out the steps to identify the x and y. Okay, so I hope you understood. Thank you so much.